Let's talk about our JiTickLogic library. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous videos, we started working on our glibs system that contains many different modular libraries. And so far, we had the fluid machines, the energy machines, and a library that provides many different abilities to write your blocks easier, write the block entities easier. We went so far to add a machine block entity that contains fluid, inventory, and energy. In the last video, we talked about crafting, and I talked about having a JiTickLogic system that is actually working with concept of behavior trees and would be modular enough to handle anything like crafting or any other logic. Now, before we dive into code and start implementing anything, I want to talk about what is a behavior tree and how does it help us in the world of Minecraft modding. This application is called behavior number 3. There is a GitHub for it, but to be fair, it's a very generic application. It's a little bit hard to use it, especially if you want to design your behavior tree faster. Maybe in future, I will start my own project for a behavior tree designer. That designer will not export any node for you, just for you to do brainstorming. Because of this, I may not start it anytime soon. So if you want to, you can just look into this name, behavior tree, and the word GitHub in Google, and eventually you will find it. Now, inside our projects, I started a little thing that will show how a behavior tree works. This is a behavior tree. A behavior tree is a collection of modular pieces of code. Each one of these white boxes is a node, and each node has its modular code that is not gonna depend on any other thing. As you see with these lines, we can connect one node to another or one node to many nodes. As you see here, we have one-to-one connection, and the other ones have one-to-many connections. And each node will know what children it has. For example, this node knows that it has 3 children, and it will take these children in order. Now, normally in any 3D game application, the behavior tree editor will sort the order of these nodes based on a criteria. For example, left to right. Or if it's a vertical designer, it will go from top to bottom. However, in case of our usage, we don't have any editor inside Minecraft development environment. And if we are using any third-party application like behavior tree, it will not export anything useful for us. Yes, I think it can export JSON, but it's not usable for us to read and parse that JSON and create our nodes and do things on the fly by code. So the way we will use this concept is that we will add nodes one after another and make the connections. And when we are making a connection, we will do them in order. So for example, if we add this connection first, add this connection second, and this connection as the third entry, when this node wants to tick, it will tick this path first, then this path, and then this path. So it will ignore the order that we designed, but it will accept the order that we make connections and add things as children. Beyond this, each tree starts with a parent node. This is the root node. By default, this root node is responsible of finding the very first node that it should tick. When we tick a node, well, regardless of what will happen inside that ticking logic, at the end of the tick, we will return a value to our parent. So each node knows what is his parent. And at the end of the tick, we have few different states for this node. Either we return a success. So a success means that, hey, I did everything I had to do. I'm finished, I'm done, and everything went smoothly. So you have nothing to do with me anymore, and you should do whatever you need. Or we can fail as the result. This means that, hey, I tried to do my things, and somewhere in my logic, I got error, or I couldn't handle what I need to do. So I'm failing. Now, you know what to do with this fail. I don't care. I just failed. The third result is running. When you return running, it means that, hey, stop doing anything else. I'm still busy. Wait until I'm finished. In the next tick, come back to me. Let me see if I finished what I need to do or not. An example of this is when in a game engine, you have an agent. Maybe it's the NPC or enemy, and you have a target, okay? Let's say that this NPC needs to go there. A simple example of patrolling. So this NPC needs to go there. The root will find its first child, and this child is responsible of seeing if this guy is there or not. Well, guess what? It is not there. So it will return fail. Now the second node somewhere will be triggered. If this was success, then we wouldn't progress forward. I will talk about the flow logic later in this video, don't worry. But sufficient to say that if the first node fails, it means that I'm not at the target position. So just do whatever you need. And this node, the parent node, will say, okay, go to the second node. And this second node says, find the first target. And if it succeeded, start moving toward it. And then it will return success, okay? And that's it. So at that time, the logic will start moving the agent. Now, in the next tick, the agent is here. The first node that first time returned failure will check if it's at origin. Well, it's not at origin. Is it at target? No. So then it knows that the agent is moving toward target. So what should it return now? It's not at the origin, so it can't fail. It's not at this target, so it can't send success. This time it will return running. And the parent node will notice that, okay, I'm moving around, so if I don't need to attack anything or anything else, then bail out. I'm finished. The parent node will be return the status of running. Now, the funny thing is that each node will return its result to the parent, and the parent will handle those results based on his own logic. For example, he has finished crafting, will return his result to crafting JiTickLogic. And crafting JiTickLogic will make the decision based on this result. And then if he has a return value and he needs to return, he will return his own value to the parent node. Now, if the parent node is the root node, we know that we have done everything in the tree that we can do, and the tree will bail out and finish that tick. So in other words, if we have these many nodes here, for example, we will finish the tick when the crafting JiTickLogic is finishing and returning to the root. Either it will return success, failure, or running, it doesn't matter. The root will return that value to our main mod, and now the main mod knows what to do with that result. Now the flow of logic, other than a child returning to the parent and parent goes up and up, is that sometimes we have a sequence, and sometimes we have a selector. Sometimes we have an action node. So basically, most of the time we are working with one of these three flow logics at the very top level of programming. Either we are a selector, or we are a sequence, or we are an action. This is the very, very generic top level concept of flowing logics. Now, a selector most of the time is marked with a question mark in our different editors for behavior trees. Sequence most of the time is marked by an arrow, and action nodes may not be marked by anything, may be marked with something else at sometimes, but normally they are not marked. Let's start with action. Actually, that's the simplest one. An action node is a node that does a job. This is the most used node in any hierarchy, because if I take a look at this hierarchy, for example, here, these two are action nodes, this is action node, and then this is action. Actually, these are sequence, and this is an action node. But as you see, we have these two that are marked like there is a hierarchy there. Let me zoom there. Look at the icon. These are sub-trees. Basically, a tree can contain a child tree. So when the node will try to run the has energy, it will say that, hey, I'm another sub-tree. So we will fall into this sub-tree here, okay? And as you see, we have three action nodes at the end. And these three action nodes are actually doing anything they want and turn their results higher up and go up and up. When the parent node in the has energy subtree is finished, it will return its value to the start crafting. Then it will go to another node has fluid. Hey, I'm another subtree. Okay, we'll start action node, action node, action node. So as you see, action nodes in the terminology of behavior tree, we call them leaf nodes, leaves, because each one of them looks like a leaf at the end of a branch. And that's where that name comes from. So An action node is just doing something and returning a value based on the result. We have selector nodes. Now, a selector node will take the very first child it has. If this child returns success, then that's the thing. The parent node will bail out. It will not care about anything else here. The first child that returns the success, that's it. I'm done. The parent node will go out. The selector node will bail out. If the first node fails, that is when the selector node will go for the second child. And if this child returns success, again, the selector will bail out. If the second node returns failure, then the selector will go for the third child. And if this third child is the last child in his list and this one returns fail, only then the selector will fail out. Okay, that's the selector. Basically, the very first time we succeed in our children, the selector is gone. The sequence, on the other hand, will try to run every single one of its children in order, and when one of the children fail, it will immediately go out. Please review these few minutes in the video about the sequence and the selector. Basically, the selector is like an OR operation, okay? Let's say it like this. An OR operation, no matter how many OR conditions we have, the moment one of them is true, that's it, the result is true. The sequence, on the other hand, is like AND. So if we have 3 AND conditions, we need AND here, true there, true here, and true here. The moment one of the conditions fail, the result will be fail, okay? So think of the selector as OR and sequence as an AND operation. From then, things will make much more sense for you. Sufficient to say, when we have a selector, we just need one child to be success and we bail out. In a sequence, the very first time we fail, we bail out. Only when all the children of a sequence return success and the last child returns success, that is when a sequence will return success. There is another thing inside behavior trees other than the subtrees and the sequence and the selector and the root node that is important, and that is what we call decoratives. Now, decoratives are things that do something special. For example, a not decorative will reverse the result of its child. For example, no progress returned success, this node will return fail. No progress returned fail, this will return success. Only when this one returns running, this guy will return running. Understood? Another one of these decoratives are the condition nodes. Now, I did use question mark both here and for a selector, but notice a selector is out of a circle. This one is sitting inside the circle. This is a condition node. A condition node normally has 2 children, okay? And these 2 children normally are either action node or a sequence or a subtree, anything else. It can be anything. Now, if the condition returns true, it will only go to this path. If the condition is false, it will go to the second path. In the concept of Minecraft, we don't want to make things more complex. So the condition node, in our case, will be changed from a concept of behavior tree. If things are true, then the condition node will return success. If things are false, the condition node will return fail. As simple as that. I will not expand things below. Let's talk about the example that we have here. This is a crafting logic. We are assuming that we may have fluid or we may not have fluid. We may have energy or we may not have energy. We don't know. So we need to handle each scenario and make a crafting tick logic as a robust tree. This crafting logic will do only one thing. Either we want to start the progress, or we want to finish the crafting, or we want to continue the crafting, the process. We can't do all of these. We can't start the process and continue and finish the crafting in single tick. So here we are using actually a selector, because the very first time we succeed on one of these, we don't want to do the other ones. Now let's say that we didn't have any recipe and we just put an ingredient and the progress should start. So we are starting from here. The very first child says start crafting. Now start crafting is a sequence, means that if we fail at any point, we will return failure. Now the first node is a condition and it says no progress, means that progress is equals to 0. If progress is not 0, then we can't start crafting. Go out and let the top node do anything else. But if the progress is actually 0, Then we want to see if we should use energy or not. Now, here is the subtree for energy. We say that we should check if we have energy or not. Here we check, should we use energy? If it says false, then we shouldn't use energy. This will return false, and the selector will go for the second branch. And here, again, we are checking, should we use energy? No. So this will return false. We will negate it to become success. And the very first time it gets success, it will return success. However, if we should use energy, then this node will return success, and this node will go for the next one, and it says has enough energy or not. If we don't have enough energy, then it will return failure. We go back up. Okay, I need to go here. Should we use energy? Yes. It will negate it. Fail. Then it fail. Then it fail. Then it fail. Okay? Now, if this fails, we can't start crafting. And that's the whole point, because we did need to use energy. We don't have enough energy. If we don't use energy, then this branch will return success, 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 success. So we will succeed here. We go to handle fluid. Handle fluid is exactly something like before. And actually, we shouldn't reduce energy here. This is just a mock-up. So again, okay, it's has fluid, sorry. Has fluid is exactly identical to has energy, but instead of energy, it will check if we should use fluid or not. And if yes, do we have enough fluid? If we shouldn't use the fluid, then that's it. We can't do anything else. Finally, if we don't have any progress and we can move on based on energy, if we can move on based on fluid, then we want to check if we have any recipe or not. If we don't have any recipe, then bail out. If we have a recipe, then please start crafting. Means that increase our progress by 1. And then this will succeed and go out. Now, in the next tick, we come back here. Again, we will tick this guy. Is progress 0? No, it's 1 this time. So it will fail, okay? The moment it fails, this will fail. Then the selector will go for the second branch. Are we finished? Now, it will use another sequence, because if we can't do the progress in process, then we have to bail out early. To see if we finish the progress or not, we check the value of progress compared to the max progress. Let's say that max progress is 10. So 1 is not equal to 10. It will fail, this will fail, and we go back here. So we say continue crafting. So is progress 0? No. So we succeed. We go back there. Are we finished? 1 is less than 10. No, this will return success. We go back. Now we handle energy, not checking the energy. We are handling the energy. Handling energy, if I find the node, is here. Now it says, should we use energy? Because if we shouldn't, then go out. We are successful. If we should use energy, do we have enough energy? If no, then fail. And we can't progress forward anymore. If we should use energy and we have enough energy, reduce the energy, and success, 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 success. So we handle the energy. Handle fluid as almost identical, but works with the fluid. This should be fluid, not energy anyway. So fluid. And then we are here. We made sure that we can progress forward. We handled the energy. We handled the fluid. Then increase the progress by 1. So now progress becomes 2. Again, in the next tick we start. Progress is not 0. Progress is not equal to max progress. Go back here. Handle the energy, handle the fluid, increase the progress. Until at the end, we increase the progress and progress becomes 10. Now this will fail. But this time, the progress is equal to max progress. Okay, we move forward, we handle the energy, we handle the fluid, and now we craft the final recipe result. That is another subtree. And again, we remove the ingredients from the input, we add the output to the output slot, we reset the progress, and we finish as success and go out. If we can't remove the inputs, we fail. If the output slot is full and we can't accept it, then we fail. And only if we can remove the items from input, add them to the output, and reset, we succeed. Here is something that I want to talk about. Now, if we don't have the ability to put things in the output slot, using this graph as it is, we will reduce the inputs, but we will not put anything in the output. That's bad, isn't it? We want to change this order. If we can add things to the output, only then go and remove the input and then reset the progress. And this is the power of behavior trees. We can easily change the order of things. In the code, what I did, instead of dragging things around, is just cut the line of adding something and paste it below the other one. Change the order. So you need to sit back and think about your logic and how you are doing things. But as you see, we already have a very robust solution for crafting logic. At least logical wise, it makes sense. And funny thing is that each one of these is a single node. This is a single node. This is a single node. Should use energy is being defined by code once, but as you see, we are using it here, 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 and here. So we defined this node once by code, but we were using it in 4 different places. Has enough energy, again, is being used twice. And not is actually being, it's very simple node that we wrote once, but we are using it 1, 2, 3, 4, 5, 6 times in this tree. And the same concept is expandable. So if you sit back and carefully observe what you want to do and think about things, chances are that you can dissect things on a modular level, and that would be it. So you code it once, and then you will end up with pieces of puzzle. For example, this time, this is energy, this is the fluid, and for example, has energy, handle fluid, has fluid, I don't know, anything else. Handle the energy, create recipe input, add input, output, reset, reduce fluid, reduce energy. As you see, a sequence, a selector. That's it. You just code the highlighted ones, and then, I don't know, maybe no progress here, and has recipe here, start crafting here, this one, and this one maybe. Okay? These are all the nodes that I highlighted blue that you need to write the code for them. And then, and of course, a root node that is a start node that is on top. And that's it. You will have pieces of puzzle that you can put together in any shape or any format anytime. Actually, when you wrote the has energy, handle energy, has fluid, handle fluid, you have a top level 4 sub trees that you can call anywhere in your JiTickLogic without caring what is happening inside that JiTickLogic. And that's the beauty of using this concept inside our modding environment. Problem: we need to plan things. I mean, just this behavior tree that you are looking at took me around maybe 1 hour to design, because I had to sit back and think, okay, what do I want to do before anything else? If I shouldn't use energy, how should I design this sub tree so that at any time it will return success? And oh yeah, I need to return a negated branch. Needs a little bit of experience and tweaking and playing with logic, reviewing only this section 2 or 3 times and make things in your brain and brainstorm and follow the logic, and then that's it, you design the tree. Honestly, you need an application that will do this design for you. I mean, something like Behavior Tree Plus that you see right now, or any other visually editing and designing behavior trees. You can even use Draw.io if you want, but I personally prefer something that is really robust and dedicated for behavior trees. Behavior Tree Plus is not bad. As you see, I have added my own nodes somewhere. Here we go, I think. I'm not sure. Some of these nodes are mine. Always success, always fail. I'm not sure if they are defaulted or not, but you can add any node at any time if you want to. For example, if I move my mouse around, the selector node and action node are not default. But long story short, you can add a behavior tree, or you can add a node here if you want to, a new one. Each node can accept an icon and a text. The thing that I don't like about this application is that if you don't want to show a text, for example, for this guy, if I remove the title, it says sequence node. So I have to add a text there anyway. I may write my own library and application for a node-based behavior tree, but I think I will use Python for that. I'm not sure. I should sit back and think about it, but the most useful library that I saw out there that I can utilize to design an application like this is actually Python. And I don't want to jump into Python in the middle of Java tutorial series regarding Minecraft and everything. But at some point, I will write a node editor that is dedicated for Minecraft design. Because, for example, although I will provide a parallel node, but a parallel node is a little bit different. It will tick every one of the childs regardless of success and failure, and it will collect the results and see if the number of successes is greater or equal than a predefined number, then it will success. Things like that are not commonly used in something like tick logic for a block entity? I mean, the parallel would look like, okay, I don't care if I can reduce energy or not. I don't care if I can't reduce the fluid or not. I will try to craft the recipe, and only at the end I will collect the number of successful operations, and then I will fail or succeed. At that time, you may not reduce the fluid, you may not reduce the energy, but you have a crafting result. It may have its uses, but if you design something carefully for Minecraft, you may be able to avoid parallel node anyway. Most of the time, you will use selectors, sequences, conditions, and decorations like not or cooldown, or I don't know, always success, always fail, random, maybe, I'm not sure, repeat, maybe, I'm not sure. But any one of these will be written in code in our library, so it's available for you. And that's it basically. So in the next video, we will start doing this. Something else that we can't show inside this application, because this is designing the behavior tree, but each behavior tree in any robust solution will have something here, okay, at one side of the editor, and that is called the blackboard. Now, blackboard is a collection of values. That's it. A collection of values. But the thing is that each node will have access to that blackboard and can read values from that blackboard. Now, in our case, in our library, our block and block entity will have properties, and each property will have fields. I'm not sure if I want to add things that are dedicated for JiTickLogic inside the property of a block entity or not. I may want to have a blackboard. As I said, I don't know. This is something that we need to sit back and think about. But the bottom line is that we should have something dedicated to carry some properties for us, and then the nodes will have access to that property, and that will be a complete solution for this design. In the next video, I will start with the base infrastructure that we need. For example, a node class, a behavior tree class, the tick status results. I may add the blackboard or may not add the blackboard. I should see. I'm not sure. I should see if I want it or not. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.